Everything we thought we knew might not be true. But let me explain so then you can make your own conclusions. This is the muon, and it's a particle that seems like the electron, but is heavier and stranger. Like all the other particles, the muon has a quantum property called spin, which is like a tiny arrow pointing in a certain direction. But if you put this particle near a magnetic field, that arrow doesn't stay still because it starts to wobble. And this wobble depends on a constant called the G factor, which the standard model, the best theory to predict how particles behave, predicts very precisely. So the standard model said that if the world works in the simple way, G would have a value of 2, but for some quantum effects, G is a little more than 2, and that's why we call this the G minus 2 factor. But the problem is not here. Scientists at Fermilab wanted to measure the wobble in the real life, so they sent muons flying near the speed of the light, but something very strange happened. The result didn't match with what the standard model said it should. We should get this number, and instead we got this one. And I know what are you thinking? Probably it's just a tiny difference, but in physics it's not tiny enough. This difference is what we call the G minus 2 anomaly, and it's very important because it could be explained by particles we never seen, forces we never name, or maybe our best theory is wrong. But let's not think about this because probably if the standard model is wrong, everything we thought we knew about other particles are wrong too. So what if instead of a mistake, it's just a message? Maybe the universe is trying to tell us that there is something out there we still don't understand. The question is, will we listen?